Okay, so we're going to look at the next type of factorizing then. So this is called difference of two squares, or I suppose dots for short, just taking the initials. So difference of two squares is a particular type of factorizing that's to do with square numbers or perfect squares. So a square number is a number that has a whole number square root. So it's ones where we can write them as like something squared. So for example, like 4, 9, 16, 25. All of these things can be written as something squared. So 4 is 2 squared, 16 is 4 squared, 36 is 6 squared, and so on and so forth. And the same thing applies then to particular terms as well. So obviously x squared can be rewritten as just x squared. 4x squared we can rewrite as 2x all squared. 9y squared we can rewrite as 3y all squared. And 16z to the power of 4 can be rewritten as 4z squared all squared, because 4z squared multiplied by 4z squared would give me 16z to the power of 4. So it's really important that you have that idea of being able to write something as something squared, okay? And think of these brackets that we have here, and the way that I'm writing this 2, the power of 2 on the outside of the brackets is supposed to signify that it's everything inside the bracket squared, as opposed to the top line there where it's actually just the letter itself that's being squared in a sense. The number then is an example of a perfect square number, so we can rewrite it easily from that idea. So looking then at our difference of two squares, we have a particular formula for that, and it's this formula in the box here, and this is an important formula for you to learn off, because this is not given to you, this is one you need to know. So a squared minus b squared, so if I have two things that I can write as something squared minus something squared, I take those two things, so the a and the b, and I write it as a minus b and a plus b in my two brackets. So when we're looking at difference of two squares questions, we have about 4 steps here that I'm going to follow. The first step is we factorize using highest common factor if possible. It's not always possible, it's not always necessary, but if it is, you must start by doing that. We then rewrite each term as something squared. So we rewrite each individual term in brackets with a squared beside it. And what that means, what that lines up for us then, is this formula that we have here. So thinking about our formula with our brackets there, that's what we're going to use then in writing it on as the two brackets there on the other side of our equal sign. So we apply our rule and then we check that we are fully factorized, that there's nothing more that could be factorized out of any of the brackets or anything like that. So looking at this first example, we have 4y squared minus 25. So taking each term individually, 4y squared can be rewritten as 2y all squared. 2y all squared. The same thing for 25. 25 can be rewritten as 5 squared. So I have 2y here and I have 5 here. Applying my rule then, I'm going to have two brackets, one bracket with a plus, one bracket with a minus. I start with my 2y, I'll do 2y minus 5, and I'll then do 2y plus 5 as my two brackets there. Okay, rewrite it as something squared, then move to the brackets. For the second example here, we have 50x squared y squared minus 72x squared. So looking at the letters, it does look like it might be a difference of two squares, but the numbers do not line up with that. The numbers don't follow my idea of it being a difference of two squares. So we have to take out a highest common factor here. The biggest number that will divide into both of these is just going to be 2. So we're going to take out a factor of 2. And I can also take out my x squared, so I'll do that. So that leaves me with 25y squared minus 36. Then taking what I have in the middle here, I can leave my 2x squared on the outside. I can rewrite 25 as 5y all squared. And I can rewrite 36 as 6 all squared. Then moving on, I have 2x squared, I have my 5y minus 6, and I have my 5y plus 6. Okay, and that's my end result there. Okay, and I can't go any further with that one there, and it is appropriately fully factored. factorized. We couldn't factorize that any further. So the key thing with all of these, I suppose, is first step, rewriting them as something squared. That's really, really important. And you can see that here we've loads of examples for you to work on, and you can see that idea throughout those examples. So I have some examples here that are straightforward, just doing difference of two squares, and I have some examples then that we're looking at, or some questions I should say, that you're looking at where you will have to begin by taking out a highest common factor for those questions. Now, the main things, I suppose, in recognizing a difference of two squares is that we're looking for this general idea here. So something squared minus something else squared. And it's important as well that we have a minus between them. If it was a squared plus b squared, that is not a difference of two squares, because the difference part comes from the fact that it's a minus. So we're looking at what's the difference between two squared things. That's kind of where the idea or the name for it comes from. So the first step, rewrite each term as something squared and then apply your rule. So really, really important for these types of questions that you learn off your rule, and then that you get some practice of these types of questions, of those exercises there in your worksheet, in your revision sheet.